let us look at operations with self. That is, let y take part in arithmetic operations with itself. There are only 4 such operations that we have interest in. The first is when y is being added to itself. Y plus y plus y plus y plus y a number of times plus y. What is the answer going to be? We know that if y is being added to itself, the number of times it adds to itself is not limited. Y can add to itself once, it can add to itself twice, it can add to itself 3 times. It can add to itself just any number of times at all. This is why these dots here are written, so that the dots indicate the other additions in between before the last y added to itself. To get the answer to this kind of expression, let me perform a simple numerical experiment. Please watch. Now see the experiment. The first one says 2 plus 2 plus 2 plus 2 plus 2. I chose 2 because 2 is a constant that all of us know. Y is not known to anybody, it could be anything. Let that y be 2 at this point. If 2 is added this way, we can also say that this 2 plus 2 plus 2 plus 2 plus 2 is the same thing as 2 times 5. When written differently, we can call it 5 2s. 5 2s, that is 2 into 5 times. So this 5 here tells us how many times 2 was brought and added to itself, or how many times the 2 appeared when being added to itself. 1, 2, 3, 4, 5 appearances in this addition. So this 5 tells us how many appearances of these 2 when 2 is being added to itself. Therefore, the result of this number operation is this. I hope you agree. What about this one? 9 plus 9 plus 9. This also means 9 brought into 3 times, or 9 times 3. 9 times 3 simply means 3 9s. 3 9s. I hope you know and remember that this is 3 9s. If this is 3 9s, please compare it with the first result. If this 5 indicated how many times 2 appeared when being added to itself, what about this 3? Does this 3 also indicate how many times this 9 appeared when being added to itself? Yes. Watch it here. How many times did this 9 appear when being added to itself? It appeared 3 times. That is what this 3 is. These 2 appeared 5 times. That is what this 5 is doing here. Okay, now, what if it is y, which is any other number at all? Y plus y plus y plus y plus up to this plus y. These dots here simply show we don't know how many times they appeared. So at least we know that y is the one being added to itself. That means y must appear in the final result. But are we going to write it as 5y? Because if you come here and say 1, 2, 3, 4, are you going to write 4y? Simply because you have seen y appear 4 times. Without these dots, you'll be right if you write 4y here. If you wipe off this one and wipe off the dots, y will appear only 3 times. That means that y plus y plus y will give us 3y. If y appears 2 times in the process, the answer will be 2y. But now we don't know how many times this y appeared in the process of being added to itself. Let small n represent that number of times the y appears. Because of that, what will the answer be? I'm asking. Y plus y plus y plus dot 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 plus y is equal to what? From my approach so far, what will you say the result will be? Let me write the result and you compare it with what you are thinking. Please check out for what comes next. And that is it. The answer is equal to ny. Check the first one. The 2 is being added to itself. The 2 is here. 9 is being added to itself. The 9 is here. Y is being added to itself. The Y is here. Okay, Y is not settled. What about the N? Okay. 2 appeared 5 times here. See the 5. 9 appeared 3 times here. See the 3 here. Y appeared a number of times unknown to us. N now means the number of times unknown. Therefore, the result of this is equal to what you have here. Please put it here. That is it. It is equal to ny. I believe that this is clear. Further, let me give some examples specific to y without using just pure constants so that we know exactly what this n represents. Please see some examples that follow that will help us exemplify the use of this small n in connection with this first operation. And now see the examples. The examples will show us a few things. 1. The real meaning of this small n. 2. That it is possible to use other alphabets apart from y. Y is being used here only because of choice of the presenter. Any other thing, any other alphabet could have been used. It's just a choice. So now that we don't have dots in these operations, y plus y plus y plus y. At least y is here. Appearing how many times? 4 times. Therefore, y plus y plus y plus y is equal to 4y. What about c plus c plus c? C is here. Appearing how many times? 3 times. C is here. Therefore, c plus c plus c is equal to 3c. What about x plus x plus x plus x plus x? X also can represent any number at all, like y and c. So x plus x plus x plus x plus x, x is here. It appears how many times in the process? 5 times. See the 5 here. Therefore, these things are just some examples selected to showcase the fact that this n can take any value at all. In this first operation, that n, which was not known before because of these dots, has become known as 4 because the number is now definite. No dots are here. Likewise, that n that was not known before because of these dots is now known in the case of this second example. Because it appears 3 times in the process, the thing is straight. No dots here, no dots here. That gives us that n, in this case the n is 4. In this case our n is this straight. In this case our n is this 5. I hope this result of ny makes sense to you. Let us look at second case. The second case in this case is this y minus y. It means a number taken away from itself. If this sign is a sign of subtraction, let it be that a number is taken away from itself. If y is 10, then any place you see y, it is 10, which means 10 minus 10. What will it be? If y, for instance, is 5, you say 5 minus 5. What will the answer be? Whatever the value of y is, if you take y away from y, nothing is remaining. So what is the answer? The answer is nothing. How do I put nothing? It is 0. So the answer is that y minus y is equal to 0. Please watch out. And that is it. Y minus y is equal to 0. Logically, I believe you know why it is so. The next is number 3. That is y times dot 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 times y. What will the answer be? Again, let me perform a simple numerical experiment. After that, we come back to this one and tell the answer. And here comes the simple experiment. I'm using 2 as a case in point. We have 2 times 2 times 2 times 2 times 2. If you get the answer to this number operation, you discover that the answer is 32. 32 is in its ordinary form. If you keep that number in its index form, you discover that in index form it is equal to 2 to the power 5. This is another way of keeping numbers. Here, the 2 is the number multiplying. And here, the 5 is number of times it appears multiplying itself. Therefore, 2 to the power 5 passes a message. What is that message? It means let 2 keep multiplying itself and appear 5 times in the process. What about this one? 5 times 5 times 5. What number is multiplying itself? 5 is multiplying itself. First, what is the answer to this multiplication? The answer is 125. That 125 could be kept in this form, index form, 5 to the power 3. Perhaps you have an idea of index form. If you don't, you're going to do it in a short while. 5 times 5 times 5, which is equal to 125, could be cast as 5 to the power 3. This 5 is the number multiplying itself. What about 3? It is number of appearances when multiplying itself. This number below, which is 5, is called the base, while this number on top is called the power. So base 5, power 3, base 2, power 5. The next one is just 7 times 7. What number is multiplying itself? It is 7. How many appearances did 7 make in the process of multiplying itself? It made only 2 appearances. That is why this 2 is here. Therefore, 7 times 7, which is equal to 49, can also be cast to be 7 to the power 2. The base is 7 and the power is 2. Base 2, power 5. Base 5, power 3. Base 7, power 2. We name it 2 raised to the power 5, 5 raised to the power 3, 7 raised to the power 2. Now, the number featuring here is 2, the number featuring here is 5, the number featuring here is 7. Imagine that any other number called y is featuring. What statement would you like to make as a statement that realizes it when a number multiplies itself? That is y times 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 y. To get the answer, let us first of all realize that in this first case, 2 appeared because 2 is the one multiplying itself. In second case, 5 appeared as the base also. In third case, the same 7 appeared as the base. Therefore, the number multiplying itself certainly appears as the base. Therefore, let me get a sketchy answer by first writing y, because y is what is multiplying itself here, not minding how many times it appears in the process. But if I write y, what follows? It is number of times it appears. This appeared 5 times, and that is why 5 is here. It appeared 3 times here, that's why 3 is here. It appeared twice here, that's why 2 is here. This one appeared how many times? You don't know. Let small n represent the number of times it appears when multiplying itself. So n will be used in conjunction with this y. Will it still be ny or y raised to the power n? Obviously, the answer is y to the power n. Please see it. And that is it. Y times times 1 times y is equal to y to the power n. I think that what happened here made this answer clear to you. We now export this and put it here. So y times 1, any number of times is equal to y to the power n. That is it. This times itself, the number of times is equal to y to the power n. That takes us to the last one, the fourth one, y over y. A number divides itself. Take for instance, if y is 20, that means 20 over 20. In fact, let me show a few things here that will show that the answer we're going to get is correct. Please watch out. Look at these examples here. 3 over 3 is equal to 1. I hope you know why. Let 3 persons divide 3 things, or let 3 persons share 3 things. If 3 persons share 3 things, each person's share will be 1. If 1,000 persons share 1,000 things, one person's share will still equal to 1. If 20 persons share 20 things, one person's share will still equal to 1. So if any number of persons share the same number of items, what is the result? Actually, the same thing is going to happen. It is equal to 1. And there it comes. It says y over y is equal to 1. What it means is that whenever a number divides itself, the result is equal to 1. Do not forget that this y means any number in any form at all. That number could appear as a constant, it could appear as constant mixed with variables. It can also appear as pure variables. Whichever way, whichever case is applicable, whenever a number divides itself, the result is equal to 1. 3 dividing 3, 1 is the result. 1,000 dividing 1,000, 1 is the result. 20 dividing 20, 1 is the result. Any number dividing that same number, the result is equal to 1. Let us now pay attention with the last, which is operations of the bundle with other numbers apart from 1, 0, and self. Let's find out. Right, and here comes the last one. It is arithmetic operations of y, that's a bundle with other numbers. Let any other number apart from 1, 0, and self be k. K can represent any number. That number could be a variable. It could also be a constant. No matter what it is, let that number be k. So when any other number k is added to y, what is the answer? If we know what y stands for and what k stands for, we can get the correct answer. So we can condense the two to one number. But for the lack of knowledge of the values of y and k, we are unable to write a single outcome for y plus k. Because of that, the answer to this inquiry is that it is irreducible. Y plus k stands for y plus k, meaning that y plus k still produces y plus k as the answer. That means the answer is irreducible. Let me put that down, please. And that is it. Y plus k is equal to irreducible. That means the answer is y plus k. What about y minus k? The same thing is going to happen here. If we know y and we know k, we can tell a single last and final answer to y minus k. But because we don't know what this y is and we don't know what this k is, the answer is also irreducible. Let me again write that. The next is that of y times k. Let any other number multiply this y. Let us perform or see a simple numerical experiment that will help us come back and give the correct answer to this inquiry of y times k. Please watch out. And here comes the experiment. We choose 2 here as a case in point to multiply with this y. This y is still what it is here, times. Then let this constant be 2. And in this case, let that constant be 5. In this case, let that constant be 3. It thinks that this constant can take anything at all as a form, either a variable or anything else. Right? So if we have y times 2, is it soluble? That is, can we solve it? The answer is yes. Yes, if we interpret y times 2. Y times 2 means that we're going to bring y into 2 times and add them. Don't forget the meaning of multiplication. To multiply means to have the same number added to itself repeatedly. So if I say y times 2, it means let y start adding to y, or start being added to itself, and let it happen so that it appears 2 times in the process. So y times 2 simply means y plus y. And I believe that with the past incidents with y, you can tell why this y plus y is equal to 2y. So the summary is that y times 2 is equal to 2y. This is why it became 2y. What about this y times 5? It simply means let y keep being added to y 5 times. See it here. It is y times, okay, sorry. It is y plus y plus y plus y plus y. That means let y keep being added to itself and appear 5 times in the process. This is what is playing out here. With our past subsections, we can tell why the answer to this is going to be equal to 5y. That is when a number is added to itself. Alright, what about this third one? Y times 3. Y times 3 means let y be added to itself and in the process appearing 3 times. And that will be y plus y plus y. With our past subsections, you can actually conclude that the result of this number operation is 3y. So y times 2 is 2y, y times 5 is 5y, y times 3 is 3y. What then about y times any number at all? What is the answer? It is that number times y. So here, the result is what? Please watch out. Yes, that is the result. Y times k is equal to ky. Remember that this 2 is here, this 5 is here, this 3 is here, and y is the end of all. So now it is k that we're writing. That is why k is here, and y appears at the end of the whole thing. It therefore means that anything times a variable is equal to that thing juxtaposed with a variable. So y times k is equal to ky. Don't forget that k can take any form at all. In fact, let me give you some specific examples that will make us realize that this k can take any form at all, whether constants or variables. See more examples here. Since we can see that this k can be anything at all, and even this y can turn to anything at all, the main thing is something times something, either variable times variable, or a constant times variable, or variable times variable. Right here we have y times x. Based on this law, it is equal to xy or yx. These and these are the same thing because of commutative law. What about this y times 2x? In this case, our k has become this 2x. And our y is still where it is. So y times this 2x is equal to 2xy or 2yx. I hope what is happening here is clear to you. At the same time, what about this a times b times c? Like I said earlier, this y can be anything, k can be anything. So at this point in time, I have a case at hand. What is it? Our law is featuring just 2 numbers multiplying each other, and in this case we have 3 numbers. What we do? What we do is simple. We have a times b times c, right? We can condense this a times b to become ab before multiplying with c, so that we make it appear as if there are only 2 numbers. So we first try to make this appear as 2 numbers. My method here is to combine this and this, please, b times c. If we use this method, this formula, to multiply b by c, what we get is bc, and a still stands out. So it is now as if I'm multiplying a number by a number, just 2 numbers now, but before we had 3 numbers. So by condensing 3 to 2, we have conformed to this structure and this process or a law. Therefore, a times this bc, our a is now this y, times is still where it is, our k is now this bc, so that in the end, if we have ky, it now becomes this a bc. So A times B times C is just equal to A, B, C. Let us look at the last one, please. And that is the fourth one, y over this k. That is any other number dividing this y, please. There is no point carrying out a numerical experiment. The answer is almost certain. Y over k, what is it going to be equal to? As long as this k is not equal to y, we can't get any answer from it. When any other number divides an unknown number, except the numbers are known, we can't tell what the answer would be. The only time we can tell what the answer will be without knowing the values of the variables is if the variable on top is the variable below. But because we have different numbers up and down, then we're not going to tell what exactly the result will be. Therefore, like the first two, the result of this last inquiry is what? Irreducible. Let me write that. And that is it. Y over k is equal to irreducible. It means that y over k is also equal to y over k. I think at this point, you have to test your understanding of all I've been saying from the start of this section to this point where you are. And here comes the checkpoint. It says, evaluate the following algebraic operations. Number 1, 2xy over 2xy. Number 2, m to the power 2 over m to the power 2. Number 3, g plus g plus g. Number 4, g times g times g. Number 5, x minus x. Number 6, 0 minus 7x. Number 7, 7x minus 0. Number 8, 5c times 0. Number 9, 13b over 0. Number 10, 3 times xb. Number 11, x times y times z. And number 12, ab times cd times ef.